Good afternoon, everyone. Welcome to the webinar. I'll let everyone get spooled up here for a couple of seconds as folks are joining us. But it really is great to see so many educators and researchers in the audience this afternoon. So many of you guys registered for this webinar. We do have some incredible content in store for you, some great guests who are going to share some research and cutting edge technologies that I know you'll love. And you'll be thinking about how can I apply this to my own undergraduate and graduate programs. So today, again, we're talking all about accelerating research and enhancing teaching experiences with 3D printing technology. Now, before we jump into it, I just want to mention we're recording this webinar. As you'll see, it will be available to rewatch on demand, and you will get that recording in an email later this week. You're more than welcome then to also share it with your colleagues who would be interested in this content. And you can also submit questions at any time throughout the course of this webinar. We've reserved some time at the end to pose those questions to our expert panelists. So at any point, if you have a question come up, just go ahead and submit it right away, and we'll hold on up to those until the end of today's webinar. Now, let's call up our speakers for today. So first, I am Melissa Martin. I am with ATS Lab Midwest and Mission Learning Systems. And a quick primer on who we are. So ATS Lab Midwest and Mission Learning Systems are the largest distributor of technical education learning systems in the Midwest United States. We partner with all kinds of incredible technology companies to bring this technology into classrooms and labs in K to gray all across the Midwest. And one of those incredible partners is B9 Creations. And I am joined today by B9 Creations Chief Executive Officer, Sean Anderson. And then we are also joined today by Tyler Curie, who is a PhD student over at the University of Colorado, Denver. Now, what Tyler is doing with 3D printing in his research is going to blow you away. Hearing him talk about his work, and when I say that this technology can enable a whole new level of research capabilities, I don't want to spoil what he's going to say, so I'll just leave it at that, but be ready to be amazed. He'll join us in the second half of the webinar. But for now, let's start with Sean Anderson, who I mentioned is the CEO of B9 Creations. Sean, thanks for joining us on the webinar today.
Very welcome. And I'm honored to be here, Melissa. Thanks for the opportunity.
Absolutely. So, Sean, our audience is going to find out these printers are fast. We're talking minutes instead of hours or even days. And to prove that, what we're doing in this webinar, we're actually going to start a live print. There's Will, your technician, right now. And at the end of the webinar, we're going to check back in on Will and Sean over at the B9 Creations headquarters and see if we can complete a print during the time of this webinar. So, Sean, just to get us started here, for an overview for our audience, this is the third webinar in a 3-week series about 3D printing in education. So 2 weeks ago, we were talking to a K-12 educator. Last week, we were talking about 3D printing in technical colleges and how we can really prepare students with those authentic industrial skills and what the workforce is looking for. But you guys really have a sweet spot in the university space. And let's start with those graduate and postgraduate research programs. A lot of these researchers are already using 3D printing in their work that they're doing. So when you're working with universities and when you're working with researchers, why is it that they're choosing B9 Creations over other printers that are available in the marketplace?
Great question, Melissa. And it tends to fall into just a handful of categories, but everything from they want a system that is stable and repeatable to get the research completed. We hear over and over from researchers who find that they're doing almost as much experimentation on their 3D printing technology as they are on whatever their field of study is or field of research is. And, as you can imagine, when you're trying to control variables in an equation to isolate us, whether it's a certain effect in a medical environment or a certain outcome in a chemistry experiment, you need the rest of the equation stable. And so the, industrial grade technology from B9, whether it's getting that research finalized, or as you mentioned, the speed to iterate, being able to run prints in minutes, not hours. You have grad students coming in that are available for a period or 2 periods. They don't have 8 hours a day to stand in front of this and work on this. And so, you know, things like that. And then our ability to work with very challenging, innovative materials. You have, and we'll talk more about it as we go, but a number of institutions who are really on the cutting edge of chemistry and photopolymer research that want a machine and vat technology that's capable of, working with some things that are definitely not off the shelf technologies from a chemistry standpoint, and we really excel there.
So what I'm hearing is the point of using it in research is the technology should almost be invisible, right? You shouldn't be worrying about whether your print is going to come out or how long it's going to take, or if you need something reliable, precise, and customizable so that what you're focusing on is the research, right? The end use of your research.
Absolutely. Our goal is to let our customers be the expert in their field and not have to be the expert in our field, right? That's our
Yeah,
job.
exactly. That's perfect. So now let's talk about pulling that down into the other undergraduate programs. Again, a lot of educators are already utilizing 3D printing as a form of fabrication in those programs, in their curriculum. So with the people you're using that are using B9 printers, what do they like about it from an undergraduate curriculum and teaching perspective?
Well, first, I'll differentiate a little bit between, when we think about undergraduate education, we tend to initially go to makerspace.
Hmm.
And what you typically see in makerspace is, there's a lot of FDM printers. You want something that's relatively inexpensive and you can have 50 of them so that everybody can get their hands on one. Here again, they tend to be a little more science experiment than a repeatable instrument. So when you think about the more programmatic driven needs, whether it's of a degree program or even an undergraduate, senior design project type of context, those customers are looking for that industrial grade tool that they know when the students have done the work, done the design work, done the layout and support work, and they hit the go button, it's going to go and they're going to get highly precise, repeatable results every time. In the case of a senior design project, these students are depending on that for a grade and needing to produce a part, and the printers in the makerspace being down doesn't bode well when you need that credit to
Right.
graduate. So, um, we've had a number of institutions. The University of Texas at Dallas is a great example where, they had senior design students working on a real life industry problem. And when you have an industry partner who's depending on the output from that printing platform, you need industrial grade technology, not, basic prototyping and kind of make a shape out of string type technology. Plus, that's what those employers want to know the students are capable of working with.
100%. Yeah, the relation back to the workforce, back to what industry doing, I think is what you guys really excel at. And I don't think we're going to be talking about it a ton, but I would encourage all of the attendees to look into all of the companies that are leveraging B9 in industry and understand that we're making that connection between what's taking place in the lab or the classroom and what they're going to see in the workforce. Now, I think we've got the creative juices flowing of our educators in the audience, and let's see where we can maybe plug this into very specific programs within a university. So what kinds of programs would you see leveraging your technology?
It really runs the gamut, Melissa, from, the chemistry, chemical engineering I mentioned before, that research around materials, to mechanical engineering, biomedical engineering, even civil engineering, material science, and as you see on the screen, dental programs. There are so many career fields now that rely on additive manufacturing, and this next generation of folks entering the workforce are expected to have a basic knowledge of that technology. And whether they are the technician actually working with it, or in the case of most engineering programs, they need to understand how to design for additive. It's another area that when B9 was looking at the education space and really getting feedback from customers, it's we do need a great piece of equipment, but what we really need are people that are willing to come alongside and partner with us to help our students understand how is this used in industry. And so we brought together a ton of, public-private partnerships and industrial partnerships, and it's one of the reasons why we're such a good fit with ATS Lab Midwest, is I know that's a huge focus of your organization as well. To me, that's really where the magic happens. And, 100 years ago, when I was a mechanical engineering student, shout out to you, Arlington, it was those senior design type projects where you got to work on a real industry problem that was so energizing and so exciting. And so using industrial grade technology where you can do that type of work and have someone who, actually is getting paid to be an engineer tell you, hey, this is a great result, this is a great product, this is a great design, and validate that is just so rewarding when you're a student.
So authentic applications, real world results, truly applying it to what's happening. And then, like you said, getting those results. I mean, and the same thing I think goes coming back to the graduate research. Same thing, right? This isn't just something you're talking the talk. Oh, yeah, this is great research, great technology. You guys are walking the walk. I mean, what you're talking about is being used in real research across the country and across the world, published in peer-reviewed publications. So tell us a little bit about how researchers have actually published works using your technology.
Absolutely. And I mean, Tyler's going to give you some great detail around this, as a somebody that we've partnered with on research. But what you see here are examples from things like pressure sensitive robotic skin. We worked with the Korea Advanced Institute of Science and Technology on that project. When you look at adhesive skins for underwater adhesion, these are things that, to people who aren't in these fields almost sound like Star Trek level solutions. But that was an Iowa State, Virginia Tech collaboration. Another great example, and some of the things that are near and dear to our hearts is when we can do things in the medical field. The University of Missouri at Columbia's School of Medicine partnered with the University of Minnesota on a project around 4D shape memory additive manufacturing for personalized implantation around cardiac disease. And these are the kind of things that for our employees, we aren't experts in those fields. We are not medical experts, but it is so energizing for us and our team when we can partner with those institutions and be a part of bringing some of those cutting edge research projects to life. We got a lot of folks here that's what they get out of bed for in the morning is, what customer can we help next? How do we get, you hit the nail on the head when you said, how do we get the additive manufacturing technology out of the way so they can go do the cutting edge research that they want to do? And again, I can't wait for Tyler to share the story about, the work that he's doing, but that's the huge passion for a lot of our team.
Yeah, 100%. I mean, we see that passion shine through with the every time we get to interact with your team. And to everybody attending, you will not find better service and support and passion around additive manufacturing than the team over at B9 Creations. And if you've got custom ideas or you have questions or the sky is the limit, and your imagination and creativity is really the limit with what you can do with this technology. And just reach out to us or them about like, hey, I've got this application, but I don't know if it could be possible. Let's talk about it, because I mean, it's incredible what researchers have done with this technology. And so thank you so much, Sean, for coming on, giving us a primer, talking about some of these amazing stories. And you've already mentioned Tyler a couple of times. Tyler, now's your time to shine. I think we're really, really excited now that we've heard about some of the potential to really dive deep into your story and what you're doing. So again, Tyler is a PhD student over at the University of Colorado, Denver. But Tyler, thanks for being on. Tell us a little bit about the research you're doing, and tell us about, like the big picture implications of your research and why it matters.
Yeah, thanks for having me, Melissa. So I work in the Weir Biomectronics Development Laboratory. We work on upper limb prosthetics. So big picture is hopefully this technology we're developing will eventually go into humans, but we're kind of far away from that. So I specifically work in the field of optogenetics. Basically, that's where we transgenically alter a cell to express these light-sensitive proteins called opsins. They're similar to the proteins in your eyes that let you see. And so once you get those opsins in a cell, you can basically use light to control that cell. So in the case of nerves, you could use light to activate that nerve. And our goal, in hopefully like 50 years maybe, is to have this technology in humans where we're actually able to create a sense of touch from the prosthetic. So someone picks something up, like in that image right there, the prosthetic senses that, and then it shines light on the actual nerve cells to create a sense of touch for the person. So if you didn't follow that, don't worry about the big takeaway here. It's just that you can use light to activate nerves. And that's really what we're doing right here.
Awesome. And tell us a little bit about the neural interfaces and why those matter.
Yeah, so of course, in order to get light to a nerve, you're gonna have to have something to hold a micro LED or the other light source to the nerve. So traditional ones, the top two pictures, are electrical nerve cuffs that you can just see about how they usually just shock the nerve for different therapeutic effects. The bottom two are optogenetic devices. So the one on the bottom left-hand corner is actually for the brain. Most optogenetics is done in the brain. Not very much is actually done in the peripheral nervous system, so like the nerves out in your like arm. Uh,
Mhm.
the right picture there you can see is actually one for the peripheral nervous system. It's specifically for rats, actually the sciatic nerves of rats. And the sciatic nerves are really large. So that's actually a really large nerve cuff compared to what we're actually working with. We're actually trying to take this and use this technology in mice, and we're even trying to use a smaller nerve called the vagus nerve. So I'm trying to develop a nerve cuff basically that'll hold a light source to the vagus nerve in mice.
So, I mean, it's pretty clear you're working in very, very small spaces. So, when you're thinking about creating these cuffs, in general, why was 3D printing the best method of fabrication for this research?
Yeah, so really it came down to like the ease of manufacturing. So traditional manufacturing techniques really struggle at this scale. So for like context, silicon, when you have it in very thin sheets, has a hard time curing. Also, 3D printing allows for novel geometry that traditional techniques can't normally do. And then it allows us to quickly iterate the design. So this allows us to adapt the nerve cuff to different anatomies and even, in theory, personalize it for an individual. And last, it allows us to create large batches. So if we have a cohort of mice that we're trying to do a study on, we're able to create plenty of nerve cuffs for that entire cohort all at once. We don't have to do multiple print cycles to get all the nerve cuffs that we need. Uh,
So,
Go ahead.
yeah, so I was just thinking, like, all right, you got a lot of researchers and educators, they've got 3D printers and they're thinking about, oh, wow, I don't think my 3D printer could ever make a cuff for that kind of an application. There's got to be some really stringent kind of requirements that you have for the type of material or what the print would be like to work in the physical body of a mouse. So tell us a little about those requirements.
Yeah, so the really hard difficulty that I faced, I spent over like a year working on this, is trying to find the right material because it has to be able to have high resolution when you print, which basically we define as significantly smaller than 90 micron meters. This is because the mouse cervical vagus nerve is about 183 microns in diameter. It needs to be soft. It needs to be just as soft as the nerve tissue or softer, so that way you don't accidentally damage the nerve when the nerve goes in the nerve cuff, and you're not going to damage any of the surrounding tissue. So that is defined as 5 megapascals because that's about the stiffness of the peripheral nerves. And then it needs to be flexible, which we kind of define as an elongation at break greater than 150%. This is just so that way we can easily implant it. So if we need to pull open the nerve cuff or do whatever we need to do, it's just not going to break while we do that. And last, and but not least, it needs to be biocompatible. So there are lots of different ways you can define that. Just for the purposes of us, we define that as just non-cytotoxic because we're just trying to really find a material that could work for implants long term. And that's kind of the first requirement that we have.
So you said you were working on it for like a year and you came across eventually material through B9 Creations that met your requirements. So tell us a little about that.
Yeah, the biosilicon is really what introduced us to B9 Creations and really got us started working together with them. So it's a really great material for these implants. It's got a XY resolution about 15 microns. It's really soft at 1.6 megapascals and has a great elongation of break that was at 205, which is well above what we were looking at. And then what I was most excited for about this material, it's ISO 10993 approved for 30-day on-skin contact. So for those who aren't familiar with this, this is basically a measurement or a certification that is for the material. Most materials I were looking at would say non-cytotoxic at most. So this is kind of the next level. Usually you start with non-cytotoxic, then you have 30-day on-skin contact, and then you usually hit the actual implant standard. So it's really great to see it was already about more than halfway over that line for biocompatibility for what I was looking at.
Awesome. So you found this incredible resin that was going to work for you, but it wasn't what you found right away. Like you had some failures and you had some challenges on the road to finding B9 Creation. So tell us a little bit when you began this 3D journey for your research. How were other 3D printers falling short? And then tell us about how B9 printers came in and solved those issues.
Yeah, so we looked at a bunch of different technologies. We looked at two photon 3D printers, which just were too small for our nerve cuffs, basically. And we looked at digital light processing, which is basically what B9's creations created with their printer, or used the technology their printers use, rather, excuse me. We looked at trying to develop our own resin. That just didn't work and spent a lot of time there. And eventually we turned to commercial resins. So in that left-hand picture, you can actually see a commercial resin that we tried on our research printer, and it just way over polymerized. You can kind of see the shape of the nerve cuff, but you don't actually get any function because it's just full of material because the material, like I said, over polymerized. That center picture is actually the bio-res silicon that we made with the custom research printer I was originally working on and kind of developed all the material options for. And if you compare it to the picture on the right, which is actually from the B9 Creations printers, you can see they're very comparable. And if anything, B9 Creations printer is superior to that picture. I know it's kind of hard to see, but it's just a lot cleaner.
Yeah,
So
100%.
yeah, so it just made sense that we kind of switched to their technology instead of using this custom research printer that we had been using previously.
Yeah, so tell us a little bit more about what you were able to achieve then.
Yeah, so like the top two pictures right there are that nerve cuff that I showed in the last picture. You can see a fiber optic cable that goes through it. That right-hand picture is just going to show that material is flexible and will open so I can put it around a nerve. So we actually took that nerve cuff and then actually acutely implanted it into the nerve of a mouse. This mouse has channel rhodopsin, which is a blue opsin. So in other words, when blue light shines on that nerve, you get those nerves activated. So with this left vagus nerve, when you stimulate it, you should see a heart rate reduction. So you can see in the bottom right hand graph right here, those gray areas are when the light is turned on, and that red line is the heart rate, so beats per minute. So you can see anytime that light is turned on, there's immediate drop in heart rate, which is what you'd expect if we were successfully stimulating it. So basically, we're able to confirm that this nerve cuff worked and was able to print really well with their technology.
Awesome. So let's take a look at how, some of your designs and how they all ended up with the B9 printer.
Yeah, so now that we've actually got technology in the material that works for us, we don't need to shrink this so that way when we actually implanted it into the mouse, it didn't harm the mouse. So we tried to shrink it to the absolute smallest we could. So the right-hand picture here, you can see the original design, which is the relatively large one that was implanted in the last last slide. And on the right there, you can see the final design, which is substantially smaller than that original design there on the left. The pictures on the left are some different angles of that nerve cuff to give you a good idea of what the final design looked like. But it wasn't easy to get to that point. I mean, yes, we were able to shrink the CAD, but there were some technical challenges with trying to get those features to resolve where I went back and forth with B9 Creations on advice on the post-processing procedure. And then I ended up trying my own thoughts to kind of improve that resolution through the adapting the post-processing procedure. But in conclusion, we really got a terrific design that was really small. And the next steps were kind of for us to verify that design to make sure we could actually implant this small one.
Yeah,
So
tell us about the verification.
yeah. So the left-hand picture there is sort of what it looks like when the nerve cuff's implanted. So we had 3 animals that we implanted this nerve cuff for 7 days. And we saw no harm in the animal, whether that was from weight loss or any other signs such as that, or any sort of discoloration of the surrounding tissue. So that was really promising. And we also did an acute study where we, again, just kind of put it around the vagus nerve of a channel rhodopsin mouse so that it responds to that blue light. And again, just turned on that blue light to see if we could get that heart rate reduction. And we got a very robust heart rate reduction, which you can see there in the right-hand graph. Once again, the light turns on, that heart rate drops, and we were able to do this repeatedly. So in between it being implanted for 7 days and showing no harm and the heart rate reduction, we were able to show this design worked for us.
That's incredible. I mean, that just blows my mind every time I see this and hear about it, because I mean, you talk about this can help people who have loss of limbs or have prosthetics, and like you're talking about helping humanity down the road, and enabling it with 3D printing. And again, to what we've been saying earlier is you shouldn't have to be a 3D printing expert or technician or create, and you were spending a lot of your time trying to figure this out. But what you should be focusing on is the research aspect of it. And so I just love to hear how you guys have succeeded in creating these cuffs that actually worked, that were small enough that you could get into the mice. You're seeing wonderful results. And Tyler, best of luck to you as you continue that research. I think it's going to be really great for humanity.
Thank you, Melissa.
So audience, we've talked about the technology. You've seen how it can work in undergraduate and graduate programs. You've heard from a researcher. We want to know now, what questions do you have for our experts while we have them on the call? So any questions about the technology, any questions about the research capabilities, you can go ahead and plug those into the Q&A box now, and we'll take a couple of minutes to go through those. I'll start with the first one. I think we've touched on it a little bit, but I just want to make sure we answer this clearly. Sean, tell us about the ability to do custom materials.
You bet. So really, when you talk about working with custom materials, you're talking about two different things. One is the release technology. And what I mean by that is the technology in the resin vat itself. B9 has intellectual property around oxygenated release technology as well as traditional, film-based release technology. And then the other kind of primary piece of that is control of the exposure and dosage and mechanical movements of the printer. And so we offer a software suite that is, frankly, it's the same tool that we license to some of the large chemical companies that produce 3D printing resins. That's available to researchers who want that, extreme control, and they're trying to do things, with materials that don't respond like typical off-the-shelf photopolymers. Our tool set gives them the ability to have that type of control. And then with the VAT technologies, we can tailor release forces and or amount of material required. We're working with some institutions that are, especially in the bioprinting space, you're talking about a liquid photopolymer that not only is really expensive, like maybe 20,000 bucks a kilogram, but frankly, you just can't produce it barrels at a time. These are, research materials that are being made in very, very small quantities. So the ability to customize a vat and maybe a build table to go with that vat to really minimize the amount of material required to run a print. Um, Sometimes those are the differences between fighting the technology and having the technology really be an enabler.
100%. I love that. We've heard that time and time again, but let the technology be an enabler. Speaking of that, Tyler mentioned just briefly that he worked with your team to kind of fine tune some of the settings and parameters to make sure he was getting the best print possible. Tell us about how you support researchers who maybe need a custom printer, or maybe need some help, figuring out how they can make the most out of their printer. Tell us about the support system you have.
Absolutely. Something that transparently, Melissa, our industry hasn't done a great job of is providing the consultative services and support that customers doing hard things like what Tyler described need. So we've built an entire solutions team that can come alongside of a research institution who, oftentimes you've got grant funding, you're operating on a timeline, you have a graduate student who wants to get their PhD and move on. And so rather than them fighting the technology for 2 years, we can bring our team of experts alongside the customer in partnership with ATS Lab Midwest, for instance, and help them find solutions to the challenges they're encountering to get the 3D printing process out of the way, let them get to whether it's, as Tyler shared, the right design, and it's a design iteration question, whether it's help with material parameters. He also mentioned post-processing. As you can imagine, Melissa, when you talk about these very micro scale research projects, oftentimes the printing is only half the battle, and then you've got to figure out how am I going to clean and cure this part. So talking to somebody who does that all day long, every day, giving those researchers access to that type of expertise, we just find to be an accelerant for what they're trying to do.
That's amazing. Thank you so much. And I can attest to just the incredible work that your team does. And speaking of the incredible work that your team does, I see Will in the background. It looks like we have a print, so I'm going to stop sharing. Let's see that print. Do we have it ready?
Absolutely. So shout out to South Dakota, which is where we are based. But yeah, the technology is absolutely fast. It is powerful. And, when you think about speed, in some cases, what you're trying to print is very small, but in other cases, you've got student projects. You mentioned that undergraduate environment where maybe a senior design project, I mentioned that University of Texas at Dallas situation where, frankly, they were utilizing the full build volume of our largest platform, working on a product that was several inches by several inches. And so being able to print quickly allows those students to fit the printing process into their schedule.
Absolutely. And thank you for mentioning too that you guys are located right here in South Dakota. So great American company, great Midwest company to work with. This is why we've loved partnering with you. And thank you so much, Sean. Thank you so much, Tyler. And thank you to our audience for joining us on the webinar today. Keep an eye out for the recording if you want to rewatch this or share it with your colleagues. And please, please reach out to us or to B9 Creations if you want to learn more about B9 Creations 3D printers for your own labs and programs. Have a great afternoon, everyone.